Today's video is on rate of change and slope. A rate of change is a rate that describes how one quantity changes in relation to another. Okay, so in a linear relationship, the rate of change between any two quantities is the same. A linear relationship is a constant rate of change. All right, there's a lot of words there. Here's what I want you to write down in your notebook. A rate of change describes how one quantity changes. So it describes how the quantity changes in relationship to another. A linear relationship has a constant rate of change. So make sure you have a linear relationship equals a constant rate of change. Go ahead and pause the video, make sure you have some notes on that. Okay, so for example, a computer programmer charges customers per line of code written. Fill in the blanks with the amount of changes between the consecutive numbers. Okay, so we've got a cost and we've got the amount of codes. We want to figure out how these numbers are changing. This is increasing by 50, okay? Every time there's an increase of 50 between the lines of codes. Every time it increases 50 in the lines of codes, the cost increases by 1,000, okay? So notice that each number here is the same. So if we take the changes in the lines, so how the lines change, the change in dollars, and the change in the lines, we can notice that this is our ratio. $1,000 for 50 lines. Remember, money on top, items on the bottom. Okay, so $20 per line. Okay, that's our unit rate. So the rate of change is $20 per line of programming code. All right, so if we look at this table, this shows the amount of money that a booster club makes washing cars for a fundraiser. Okay, so if they wash 5 cars, they make $40. 10 cars, $80. 15, $120. Notice that it's increasing by 5 cars and increasing by $40. So the change in money is $40 for every 5 cars, or if we write the unit rate, $8 per car. All right, so they're working at the car wash, so the number of dollars that they earn is $8 for every car washed. All right, you don't need to write down every example, but make sure that you at least have some examples written in your notebook or that you understand. Go back and rewatch if you need that explanation again. Okay, go ahead and try this for me. Go ahead and pause the video, see what you can do with this, see if you can figure out the miles a plane travels while in flight, and use the information to approximate the rate of change instead of in miles per minute. Go ahead and try it now. So let's ask ourselves, what's happening between the time? It's increasing by 30 minutes every single time. What's happening with the distance? It's increasing 290 every single time. Okay, so our rate of change, we want to know miles per minute, not minutes per mile, right? That doesn't even sound right. So we go 290 miles for every 30 minutes. And we need to figure out what the unit rate would be. And a unit rate always has a 1 in the denominator. So the miles in 1 minute. You can do this problem in 2 ways. You can just simply divide 290 divided by 30, and you would get 9 2/3 miles, which if your calculator has this 9 with the 6 repeating, remember that is 2/3 as a fraction. Okay, there's a little fraction button on your calculator. It has an F to a D, that means fraction to decimal. Your calculator can convert that for you. If you need help figuring out how that works on your calculator, I'd love to show you in class. Just feel free to ask. Okay, so we know that it's going 9 2/3 miles a minute. Okay, so that's how we work with tables. Now let's look at a graph. If we wanted to use a graph to do this, we would have to find the distance between 2 points, okay? This graph represents the distance traveled while driving on a highway. If you look and we find the constant rate of change, We call this the slope. Notice how if you were walking up a hill, la da 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 da, if you were on a hill and you were walking up it, you'd be walking up the slope. If you were walking down it, you'd be walking down the slope, okay? The rate of change is also like the guy walking up and down the slope, okay? That's one way to remember that word. Make sure you have slope equals rate of change in your notebook. All right, that is incredibly important. All right, so find the rate of change. We want to pick 2 perfect points. If ever you see a point at the point of origin, that one's always going to be the most helpful. If ever you see a nice perfect integer like 1 and 60, knowing that we went 1 hour and 60 minutes and 60 miles, 60 miles in 1 hour is already a unit rate. So we are already done. But what you can do is you can pick any points. I'll show you with the 2 over 120. So if I started with 120 miles in 2 hours, not minutes anymore, and I subtract the 60, so I took this point, and I'm going to subtract 60 and 1 in the denominator, we still get 60 miles for every 1 hour. That's the rate of change. Let's look at another example. Okay, if we look at, that's the same example, just kidding. If we look at another example, we know that this point is representing traveling 0 miles in 0 hours, okay? If we look at this point, we're going 60 miles in 1 hour. What about here? Okay, so we are going 120 in 2 hours. What about up here? Okay, is it as easy to see this point? No, we'd really truly be guessing. So make sure that you only use points that you are perfectly positive of the actual point of intersection, like 2 hours for 120 miles. Okay, let's look at another example. Here's a graph. Okay, we've got a point at the origin, 0, 0. We've got a point at 130. We've got a point at 260. And we've got a point at 390, okay? These are 90 miles in 3 hours, or 30 miles in 1 hour. Using the graph, find the rate of change, or the slope, right? They even tell you, or, in miles per hour. So we're gonna do miles per hour while driving in the city. Okay, so we wanna find the rate of change. So we're gonna pick 2 points. I'm gonna pick this one this time, and this one. We always take the greater, so 60 miles for 2 hours, and I'm going to subtract 30 miles for 1 hour, okay? And 60 minus 30 is 30, and 2 minus 1 is 1, so my answer would be 30 miles per hour. Notice this could also be the unit rate. So what does this mean? What does this point right here mean? Let's get rid of these other points so we can just isolate that point. It means that I'm going no miles in no time. Okay, makes sense. I'm standing still. I haven't gone anywhere. And what does 1 over 30 mean? It means I'm going for every 1 hour you're driving 30 miles. Or we can rewrite it like to reflect our unit rate, which would be 30 miles per hour. Okay. Let's look at another example. The table shows the hourly charges to rent a bicycle at 2 different stores. Okay, so we've got a table here and we've got a graph here. We've got pedal rentals and supercycles. We want to know a unit rate. This is kind of like a better buy question, right? Notice how everything builds. So we want to know where we would rather go buy our rental. So if I look here, the time is increasing by 1 and the cost is increasing by 12. So I know that it's going to cost me $12 for 1 hour. Here, it's costing me no dollars for no hours. That's a good thing. Here, it's costing me for every 1 hour. Notice they forgot their label. That's bad. Okay, 1 hour is $8. So $8 per hour. If you tell me in your notebook, I want you to take special note of this, that they forgot their label. And if you point out to me labels are important. I want to see that in your notebook. Labels are important. Okay, so who should we buy from? Definitely Super Cycles. If we look, I'm only paying $8 every hour, while here I'm paying $12 every hour. Okay, we're going to try more like this in class. So if you want to, rewatch the video. If not, make sure that you at least have the definition of rate of change, linear relationships, and that an example with a table, as well as an example with a graph. And also making sure that you have this slope definition, okay? And I will see you next time.